Right, I'm going to go through the June 2019 paper in preparation for you guys in a couple of weeks. What I'm not going to do is necessarily do all of the papers and just sort of focus on the ones that we think will come up based off of what's already been seen. So very much a case of predictions, but let's just see what we've got. Okay, first question. I'd be surprised if you didn't have something to do with adding and subtracting, particularly in some form of money context. Okay, so with this, you can do it in your head, but please make sure that you just take that time just to align all your place values, because that's where the mistakes can happen. So we've got 5, add the 8, gives me 13. 2, add 1 is 4, decimal point, and then I've got my £9.43. Okay, I've got minus 8, add 11, so this means I'm starting at minus 8, and because I'm adding, I'm moving up towards 0. So I've got minus 7, 6, 5, 4, 3, 2, 1, 0, 1, 2, 3. So I've gone all the way up to positive 3 because I've gone beyond 0. Multiplying. When you're multiplying two negatives, it becomes a positive. Okay, so I've got 6 multiplied by 9 gives me 54, because again I've got the two negatives make a positive. Okay, the comparison. So I've got 4.5. I'm going to put a 0 on this side so it matches. So I've either got £4.50 or £4.34. Oh, so I've got, that's it. So I've got the inequality symbol is eating the bigger number. 3/4. Okay, so if I had a whole one and I split it, each one of these is worth a quarter or 25%. So if I've got 3 of them, I've got 75% or 0.75. So this time 3/4 is less than 0.8. In my fifths, and if I've got a whole one, split it into 5 equal pieces, each one's worth 0.2. So if I've got 0.2, 0.4, 0.6, so these two are equal to each other. Okay. Okay, rounding. I'd be very surprised again if there isn't some form of rounding, and particularly with this word here, estimation. Okay, so estimation is all about giving an answer which is close to what the actual answer would be, but not exactly that answer. So we've got here, so by rounding each value to one significant figure, estimate the cost of 3.9 kilograms of apples at 87p. So the first number that you get to that isn't a 0, which effectively is your biggest place value, is your first significant figure. So for me, that is my first significant figure because 3 is bigger than 9/10. So to one significant figure, this is going to become 4 kilograms. 87 pence. Again, first and my biggest significant figure is the 8, so this would then become 90 pence. I'm looking down here and I can see that my answer's wanting it in pounds, so I'm going to do my 90 multiplied by 4 first of all. That gives me 360 pence, and then I can then just convert it at the end. So just be careful of those units. Okay, next one up. Got fractions. So at the minute we're looking for an equivalent fraction for this first one, so whatever I do to the bottom I've got to do to the top as well. So if I look at this, 7, 14, 21, 28, so that's 4 times bigger, so I'm going to multiply both by 4, which gives me 12. I've now got a mixed number fraction which they're wanting me to convert into an improper fraction. So if I've got 4 whole ones all split into halves and another half, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, the other way of doing it is multiply your whole number by your denominator. and then add on the top bits. Okay, subtracting fractions, your denominators have to be the same. Okay, if they're not, then we're going to do the kiss method. So we're going to multiply the bottoms, which gives us 15. But because our denominators have got bigger, we now need to make their equivalent fractions by then multiplying the diagonals. 5 multiplied by 2 is 10. 3 multiplied by 1 is 3. Now I can do my subtraction. 10 subtract 3 is 7/15. Right. Multiplying with decimals. With multiplying decimals, if you make values equally bigger by powers of 10, as long as you make sure you remember how many decimal places you're taking out, you can then return them and you then get the correct answer. So what I mean by this is, if I just take this number and this number, that is 2 numbers after the decimal point. So effectively I've multiplied each side by 10, or 100 in total. So I'm going to then just write 2 decimal places that I've taken out. So what I'm now going to do is just do 7 multiplied by 3, which is 21. Okay, my 21, if at the minute my decimal point hasn't been put back in, because it's at the end, and I now need to go back 2 spots. It's going 1, 2 points back here, so I've got my answer there. With division with decimals, this one's quite a nice one, because what we're looking for is, we want that second number to not be a decimal, and then it's just normal bus stop for division. So I've got 0.48 divided by 6. So 6 into 0. 6 is into 4, can't go. I carry this 4 across. Nothing gets carried from the outside number. It's always what we've not got on the inside. 6 is into 48 goes 8 times, and we've got our answer. So for that question, we don't need to do anything fancy like this. It's just straightforward division. Okay, next one. We've got 5 squared, so that means 5 multiplied by 5 gives me 25. I've got the cube root of 64. So what I'll look at is, I'm going to go through and look at the numbers that are cubed that I do know. So 1 cubed is 1 multiplied by 1 multiplied by 1, which is 1. 2 cubed, 2 multiplied by 2 is 4, multiplied by 2 is 8. 3 cubed, 3 multiplied by 3 is 9. 9 multiplied by 3 is 27. And then we've got 4 cubed, so we've got 4 multiplied by 4 is 16. 16 multiplied by 4 is 64. So this base here of the 4 is the cube root, because that's the number that we have multiplied by itself 3 times. Because I've wrote this out, I can now use this. 2 cubed is 8, multiplied by the square root of 49, which is 7. Okay, and I've followed BIDMAS, indices before multiplication. 8 lots of 7 gives me 56. Okay, so far I'd be surprised if that sort of stuff didn't come up. Right, if we have a look. Oh yeah, definitely this page as well. It's quite a nice paper actually. Oh, lovely. Right, find the output when the input is 7. So I'm putting a 7 here. 7 multiplied by 5 is 35. 35 subtract 3 gives me 32. This time it's saying find the input when the output is 42. So this time I'm coming on the outside and I need to come backwards because I've got my answer. So I've now got 42 add 3 is equal to 45, and then inverse divided by 5 gives me an input of 9. The last one, again, a very common question that could come up. The input is x and the output is y. Write an equation for y in terms of x. So what that means is I need to start with y equals. So my output here is going to be y and my input is going to be x. So on here, to get to y, I need to do x multiplied by 5, which is 5x. Then I need to subtract 3, and that would then tell me what my y value is. So it's just effectively putting the letters and then writing that little equation in there, but everything's done for you up here. Okay, no angle stuff's come up as yet, so I'd be surprised if it doesn't come up. Hopefully paper 2. If not, I'd be surprised if it didn't come up then again on paper 3. Right, we've got AB, which basically means A to B, this line, and CD are parallel. So these are two lines that never meet, always equal distant apart. EF and FB are straight lines. Okay, so these are called our transversal lines. These are the lines that travel across the parallel lines to then form these angles. Complete the following statements. X is 55 degrees, so it's telling us it's 55 degrees because what I'm looking for now is I've got parallel lines. This is my transversal line, and they are on opposite sides of my transversal line. So because they're on opposite sides of the line, these are on alternative sides of the line. Oh, I can't spell equal. Change that. Okay, and alternative angles are equal. Effectively, this angle is copied and pasted here, and then this angle is copied and pasted on this whole bit, including the y. On here, it's saying that y is equal to 70 degrees because. So this time I need this corresponding line, so the transversal line, I'm just giving the answer. So with corresponding angles, which is the answer, they're both on the same side of this transversal, so you can see they're both on this left hand side, but then also on the parallel lines, they're also on the same side of the parallel line, so both on the left of the transversal, both above their touching parallel line, so both on the left, both above, so that everything's corresponding, it matches. Okay, and again, corresponding angles are equal in size. And effectively, again, copied and paste, copied and paste. Right, probability. So it says here, Darren has these 20 crayons in a box, and then we've got our different values. He chooses a crayon at random. What letter is the probability of a blue? So first thing I'm going to do is I'm going to get a total. So I know it's got a total. So even's chance would be equal to 10 because it's half. So I know that up here 20 and obviously 0. So I'm going to go for C because there's 8 and that's the closest to the D. Yellow, I've got blue, red, black, green. So there's no yellows. So I've got the letter A. I've got 0 chance. Don't make that mistake I almost made. Make sure you use the letter. And then not black. So if it's not black, if I take that black out, that leaves me with 15 left over, which is going to be more than 10. So I've got the E. Darren buys 16 more crayons that are either blue or red. He puts these into the bag of 20 crayons he has already. He then picks a crayon at random from the box. The probability he picks a blue crayon is evens. How many reds? Right, so what we know first of all is we've got 8 is blue, 4 is equal to red, 5 is our black, and 3 is equal to green. So we are only adding blue and reds. So the first thing I've got, I started with 20, I'm now adding on an extra 16. So it gives me 36 crayons. Blues is even, which is half. So I've got 36 divided by 2 gives me 118. So my blues needs to go from 8 up to 18. So that means I'm adding, of those 16, I'm now adding an extra 10. So 8 add 10 gives me that 18, that evens chance. Because I was adding 16 and I've just used 10 of them over here to increase, that leaves me then with 6 left over for my reds. So I had 4 reds, I need those extra 6, which means that in total I've got 10 reds. Okay, graph shows Sarah's journey from her home to a shopping centre. So we've got shopping centre, we've got everything labelled, timings and stuff looks good, so there's no sort of errors in the graph. So state an assumption that was made when the graph was drawn. Okay, so if we look at, if we're using straight lines and they're diagonal, that would represent a constant speed. So we then just put that Sarah travelled at a constant speed. What is the distance from Sarah's home to the shopping centre? So we've got home to the shopping centre, so let's have a look. So we've got 31, 32, 33, 34, 35, so that doesn't work. 32, 34, 36, 38, 40, so that does. So 2, 4, 6, so 36 kilometres. Between which two times did Sarah stop? Explain how the graph shows this. So she stopped here to here. And a stop is a horizontal straight line. And the reason for that is time continues to tick, but the distance isn't increasing or decreasing. So we've got 1, 2, 3, 4, 5, 6. So she's stopping at 10:30 until 11. And it's shown by a horizontal line. Okay, if you want to add on, this shows time increasing, but the distance staying the same. Right, next question links into the graph. So it's saying Sarah stays at the shopping centre until 1 PM. She then travels home without stopping. The journey takes 40 minutes. Complete the graph to show the information. I'm going to go back to the graph. So she's staying at the shopping centre until 1 PM. So I've got okay, so she's stayed. So I've got this point here. So I'm going to get a nice ruler. I'm going to draw straight along. Then says it took her 40 minutes to return home. So let's have a look. So 10, 20, 30, 40, 50, 60. So each one's worth 10. So 10, 20, 30, 40. So I need my line to then come down to that point. Okay. So using a nice straight edge. I ain't got a ruler with me. Hopefully I don't need any questions. So I'll use this lovely placemat. One, and then again, nice straight line all the way down. Okay, my graph is then completed. Okay, the next question says, work out Sarah's average speed for her journey home. Okay, give your answer in kilometers per hour. So first thing I know is my time's already told me up here, which is 40 minutes. Okay, so the next thing I need to know is that distance again, which was 36. Okay, so I've got distance equals 36 kilometers. Right, one of the issues that I could now face is the fact that I need to make this in kilometers per hour rather than kilometers per minute. So things that I'm going to think about is this. First of all, 60 minutes is equal to 1 hour. So whatever distance I can get done in an hour, that's my speed. Right, so with this, if we're on a calculator, we'd be talking about, we could use that time button and all of that. But what I'm going to look at is now, how can I get this number to either go directly to 60 or make a jump in between? So what I'm going to do is, I'm going to set it out like this. I'm going to do 40 to 36, and because I'm going a constant speed, I can do my average because I can use direct proportion. So I'm going to half these because I know that 20 goes into 40. So divide by 2. So that gives me that in 20 minutes I will have travelled 18 miles per hour. And then on here I've got 20, 40, 60, that magical number. So I'm going to now take it up to 60 and I'm going to multiply it by 3. Okay, which effectively is 2/3, which is what 40 minutes is. So 18 multiplied by 3, 8, 16, 24. 3 multiplied by 1 is 3, add the 2 is 54. So my speed is 54 kilometers per hour. Right, next one. There was a little bit of this on paper 1, but I would imagine it's going to come up. We had a bit of this, but we definitely didn't have anything to do with adding and subtracting. So I imagine there'll be some form of that on your test. So I'm going to write it out. So I've got 3t, add 5u, subtract 2t, add 3u. Now I can simplify these terms. So I've got 3t's subtract 2t's gives me 1. Both of these things are positive. So I've got 5 add 3 gives me 8u, and because they're both positive, it's positive. This subtraction sign has been used to do the subtraction, so I do not need to use it again. So I've got t add 8u. The only time I want to see a subtraction sign in between would be if one or both of these values ended up going down into the negatives. And here I've got 6 multiplied by 2 is 12. A multiplied by a squared gives me a cubed. Okay, everyone's favourite, rearranging the subject and making a different value the formula. Right. With this, it is just like solving an equation. What we are trying to do is get the x on its own, whereas at the minute the y is on its own. So the key thing is going to be inverse operations. First thing we get rid of is the subtracting 1. So I'm going to add 1 to both sides. Minus 1 add 1 is gone. So that leaves me with x squared. Because I've got nothing to add 1 onto, I'm literally just writing y add 1, which is what we want to do. Effectively, we're trying to transfer it over. The inverse of squaring is square root. So we're going to square root both sides. So the square root is x. And then over here, we've then got our square root symbol over everything. Okay, so now I've got x on its own. X is equal to the square root of y plus 1. Right, next page, scatter diagrams has come up, and there was quite a few marks on there, so it will come up on your statistics. I don't think it will come up again. Right, we've got some measurements and conversions to do. Again, there was a similar sort of question to do with the millilitres and the 5 litres, but we'll have a look just in case, because this is a different form of converting. So it says Kate is 5 foot 2 inches tall. Alice is 1.57 meters tall. Alice says that she is taller than Kate. Use the conversion below to decide if Alice is correct. So let's have a look. So let's deal with Kate. So it's saying that 1 inch is 2.5 centimeters, and it's saying 12 inches is 1 foot. So at the minute she is 5 foot 2 inch. Okay, so now I'm going to deal with this, which is going to be 12 multiplied by 5, which is this bit, turning my feet into inches. The reason I'm doing that is inches is there, inches will then help me get into centimeters. So I've got 60 inches plus I've got her extra bit, so Kate is equal to 62 inch. I'm now going to use this second conversion, and I'm going to convert her into centimeters. So I'm going to do 62 multiplied by 2.5. The way we can multiply by a half is effectively, so like for here, 62 multiplied by 2.5 is the same as doing 62 multiplied by 2 gives me 124, but also 62 multiplied by 0.5 for the half is the same as dividing by 2, which is 31. And we then add them two together, I've given myself that 2.5 times, so I've got 5, 5, 1. Okay, so Kate is 155 centimeters. Okay, Alice is 1.57. So if we were to put this in meters, that would be 1.55 meters. So Alice says that she is taller. Use the conversion to decide if Alice is correct. So Alice is 2 centimeters taller than Kate at 1.55 meters. Kapow. Right, recipes. This, I imagine, will come up. Okay, using that proportion and ratio knowledge. So the first thing I want to know is what the recipe is making for. What you'll find is these first two questions are fairly nice, and then you get a more of a chunkier application question. But again, this is a very similar format, how you may well see it. So it says, how many eggs does she need to make 60 cupcakes? Well, 20 cupcakes is equal to 4 eggs. So to get to 60, 20, 40, 60 times by 3 gives me 12 eggs needed. Next one, how much butter is needed for 5 cupcakes? So I've got 140 grams of butter is equal to 20. I need to get that to 4 people. So 5, 10, 15, 20, so it goes in 4 times. And because I'm going from a big to a small, I'm dividing. So over here, I'm going to divide as well. Okay, so 4's into 1, 4's into 14, goes 7 times. Sorry, I'm lying. 4's into 14 goes 4, 8, 12, 3 times. Remainder 2. 4's into 20 goes 5 times, so we've got 35 grams. Okay, and then the last one with this recipe. Right, so Rashid has 110 grams of cocoa powder and plenty of other ingredients. He says that he can make at least 75 cupcakes. Is he correct? Explain your answer. Right, so on here it's saying that 60 grams is equal to 20 cupcakes. Okay, there's a couple of ways you can do this. You can convert either the grams up to 2 and 10, or you can also then just start to show what it would be and what would actually be needed for 75. So if we did this way, we've got 40 cupcakes would be 120, and then another, so we've then got 60 gives me 180, right? And I need to now add on those extra 15. So what I can then do is go, right, if I've got my 60 grams and that's equal to 20 people, if I take this down to 5 by dividing it by 4, okay, so half is 30, half again is 15 grams, then I can do the extra 15 cupcakes, so multiply it by 3. So 5 multiplied by 3 is 15, 3 multiplied by 1 is 3, add the 1 is 4. So I then need to add on the extra 45. So if I then add these two values together, that's going to give me my 75 cupcakes is equal to 5, 12, 225 grams needed. So can he make them? The answer is no. Okay, helps if I show you what I've done there. Okay, so I've just added these two together. So then my final answer would be no, he would need 225 grams for 75 cupcakes. Don't overcomplicate it and go, well, yeah, that'll be enough. 15 grams isn't very much. Make it very black and white, as in, yes, it is, or no, it isn't. This is the reason. Right, enlargements or translations, whatever it's going to be. Let's have a look. Transformations is the overarching. You have had reflection with lines of symmetry, but again, that's you never know. So let's have a look. So on here, what's nice is we've got 6 possible marks. Okay, so enlarge triangle A by a scale factor of 3, which basically means 3 times bigger from the center of enlargement. Label it B. Okay, so what we've got to do is we have got to place this in the right place because of this center, and also enlarge it to get us our 3 marks. Okay, what I'm going to do is I'm going to draw a journey across, and I'm going to go to this bottom corner here. So I'm going to go 1 square, 2 squares, 3 squares that way to the right, and then 1 square up. Okay, because I want this shape to be 3 times bigger and 3 times further away from this point, I'm now going to multiply both these numbers by 3. So I'm now going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, and then I need to go 3 up. 1, 2, 3. Okay, so this corner has now moved to there as part of the enlargement. I could do that for every corner, but because I know that I'm doing this corner and this corner, I can now enlarge the shape from here. So I've got, instead of 1 across, I'm now going to come across to 3, and instead of 2 up, I need to then come up by 6. 1, 2, 3, 4, 5, 6. Again, get your ruler out, or in my case a placemat. Okay, and then I've enlarged it. If I was to then put these lines in, you can see that from the center point, these rays should always match up and then meet at this enlargement point. Okay, and then okay,